Hello students, in this video we will solve problems based on the basic proportionality theorem and the converse of basic proportionality theorem. So let's begin with the first problem. So our first problem says DE is parallel to BC, okay, and we are asked to find EC. We are given the values of AD, the length of AD. AD is, we'll rewrite it down over here. AD is 1.5 centimeters. Then DB is 3 centimeters. We have AE, which is equal to 1 centimeter, and we are asked to find out EC. So we are given that we'll write over here solution. Now D is given parallel to BC. So if we use basic proportionality, we can divide this into ratios. So by basic proportionality theorem, we can say we can say that AD upon DB equal to AE upon EC. Now AD is what? 1.5. DB is 3 centimeters equal to AE, which is 1 centimeters, and EC is what we need to find out. So if we cross multiply, EC gets multiplied with 1.5. So we get EC into 1.5, 3 into 1. We'll take 1.5 down over here as the numerator. So EC will be equal to 3 into 1 is 3. So 3 upon 1.5. Okay. Now 1.5, if we multiply it by 2, we should get 3. So 1.5 into 2, 2 5s are 10, carry 1, 2 1s are 2, plus 1, 3.0 because of this decimal point over here, which means we can cancel this out. 1.5 into 2 gives us 3. So EC is equal to 2, and we write down the units, that is centimeters. So EC we get equal to 2 centimeters by applying basic proportionality theorem to this problem. In this problem we were given AD and DB and AE, but we were asked to find EC. We have been told that DE is parallel to BC. So when we know that DE is parallel to BC and that line DE is actually dividing them into ratios, like over here we were given different lengths of AD and DB and AE and EC. So then we can use it, use the basic proportionality theorem to get them into the sides into ratios equal to each other, the corresponding sides. And applying the basic proportionality theorem, we could achieve or get or obtain the length of EC. Easy? Okay, so it's not difficult at all. Let's solve another problem. So in this problem, we have been given that D is parallel to BC, and we are given the length of DB, which is equal to 7.2 centimeters, AE, which is 1.8 centimeters, and EC, which is 5.4 centimeters. We are asked to find out AD. So let's solve it the same way we solved the first problem. Let's write down what we have been given. So DB equal to 7.2 centimeters, AE is equal to 1.8 centimeters, EC is equal to 5.4 centimeters, and we need to find out AD. So we apply, and we are given that DE is parallel to BC. So by basic proportionality theorem, we can say that AD upon DB is equal to AE upon EC. AD is something that we need to find out. DB is 7.2, AE is 1.8, EC is 5.4. Okay, now 18 3s is 54. So even 1.8 into 3 should give us 54. 3 8s are 24, carry 2, 3 ones are 3, plus 2, 5, sorry, this is 4, 5.4. So we 1.8 into 3 gives us 5.4. We are left with 1 upon 3, and this we cross multiply. So we get AD into 3 equal to 1 into 7.2. 3 we bring down. Actually over here there is no need to cross multiply. This is just to show you that it gets cross multiplied, that I have multiplied over here AD into 3. Otherwise there is no need to multiply AD into 3. You can leave 3 where it is and just multiply 7.2 into 1 over here, okay, leaving AD on the left hand side. So just this is just an additional step for you to know and learn how this cross multiplication is done and how we get the next step. So 1 into 7.2 is 7.2 upon 3. This we can divide over here. 3 ones are 3, 3 2s are 6, carry 1.2, that is 3 4s are 12. So we get AD equal to 2.4 centimeters. This is 2.4 centimeters, and we get this once again by using basic proportionality theorem. Okay, now let's solve another problem. So our question says E and F are points on the sides PQ and PR respectively of triangle PQR. For each of the following cases, state whether EF is parallel to QR. Now there are 3 questions under this. We will have to check for each one of them whether EF is parallel to QR. So we will be given the lengths of these sides, and from there we have to deduce whether EF is parallel to QR, which means we will have to use the converse of BPT to find out, because in the converse of BPT we are not told that the line dividing the sides of a triangle into equal ratios are parallel. That is something that we need to find out. So that is what becomes a part of converse of BPT, wherein based on the ratios, whether the ratios of the corresponding sides are equal. If they are equal, then yes, we can conclude from that that the side, the line that divides these two sides which are equal, the ratios which are equal, is parallel to the third side of the triangle. So let's begin with the first problem. So we are given PE is equal to 3.9 centimeters, EQ is equal to 4 centimeters, PF is equal to 3.6 centimeters, and FR is equal to 2 centimeters. So now we need to check whether their ratios of the corresponding sides are equal or not. We need to check if P upon EQ is equal to PF upon FR. If P upon EQ is equal to PF upon FR, then we can say that EF is parallel to QR. Do not go by the figure that I have drawn. It looks parallel, but we do not know whether it is parallel or not. This is just a representative figure for you, for better understanding of how we take the ratios. There is a small correction. FR is 2.4 centimeters over here. Okay, so we will see for each one. So we will take P upon EQ first. We will see what we get. P is 3.9 and EQ is 4 centimeters. So it's not divisible. I mean, if it will go into further decimal point if we go on to divide that further. So we'll leave it over here. We'll just check with PF upon FR if there is any match. PF upon FR is 3.6 divided by 2.4. This is divisible. So 12 2s are 24. So that is 12 into 0.2 is 24. 12 into 0.3 is, say, we get 0.3 upon 0.2. Now if we happen to divide this further, we will end up getting 1.5 centimeters. Okay, now in this case, if we divide this further, we should get 0.936. Okay, would be 4 nines are 36, carry 3, so 3 4 nines are 4 sevens are 28, 10 4 5. So it obviously the two do not match, so we can say that this implies that Pf upon Fr is not equal to, sorry, yeah, Pf, write it as P upon Eq is not equal to Pf upon Fr. Okay, so therefore we can say that Eq is not parallel to QR. Okay, because we did not get them the ratios of the corresponding sides of the triangle were not equal to QR. The reason you can also say that EF does not divide the sides PQ and PR of a triangle in the same ratios. Okay, you can also write that. Okay, so I can say since EF does not divide PQ and PR of triangle PQR in same ratios. Okay, this is the reason. Fine. So the first one we got that EF is not parallel to QR. Let's take the second question. Okay, our second question is similar to the first one, but the figures, the values or the lengths of the sides have been changed. So P is equal to 4 centimeters, EQ is equal to 4.5 centimeters, PF is equal to 8 centimeters, and FR is equal to 9 centimeters. So we need to check if P upon EQ is equal to PF upon FR. So we'll have a look at P upon EQ. What values do we get? P is 4, EQ is 4.5. Leave it over here, and PF upon FR can be written as 8 upon 9. Okay, so if we happen to divide these two by 2, we will get 2 4s are 8, and here we will get 4.5 into 9. So if we divide 9 by 2, this is how we get 2 4s are 8, 9 minus 8 is 1. Okay, then you put a 0 over here, put a decimal point because you're taking 0, bring the 0 down, 2 5s are 10. Okay, so you get 4.5. So which means that PF upon FR is also 4 upon 4.5. So this implies that P upon EQ is equal to PF upon FR. So we can say therefore therefore EF is parallel to QR. Okay, why? Since you can say that EF divides sides PQ and PR of triangle PQR in same ratios. So, and you can say by over here you can say also by converse of BPT, because it is a theorem, it is converse of BPT that actually allows us to state that EF is parallel to QR. So that's the second one. Sorry, that's B. I will take one last question based on this. Okay, so this time we are given in this PQ is equal to 1.28 centimeters, PR equal to 2.56 centimeters, PE is equal to 0.18 centimeters, PF is equal to 0.36 centimeters. Now we have not been given EQ and FR. To prove, to find out whether EF is parallel to QR, we need to know what is the value of EQ and what is the value of FR. But we can definitely get the values of EQ and FR because we have been given the total length and we have been given the length of this PE. We have been given the length of PE, we have been given the length of PQ. If we subtract PE from PQ, we will get EQ. Similarly over here, in case of to find out PFR, we have been given PR, we have been given PF. If we subtract PF from the full length PR, we will get the value of FR. So let's find that out first. Okay, so we say solution and we'll find out what is EQ. So EQ, or to actually tell you how it works, this is how it works. So PQ, that is the entire length, is made up of the sides PE plus EQ. We need EQ, so I take PE on the left hand side, which will make it negative. So we will have EQ is equal to PQ minus PE. So I've just changed the side, making sure the unknown quantity is on the left hand side, that's all. So PQ is given as 1.28 centimeters and PE is given as 0.18 centimeters. Let us subtract this over here, 1.28 and 0.18. If you subtract, 8 minus 8 is 0, 2 minus 1 is 1 and 1 minus 0 is 1. So which means we get 1.1 centimeters. We found the value of PQ. Let's find the value of FR now. So for FR, we have been given the value of PR. So PR can be written as total of PF and FR. We'll keep FR the way it is, but we'll take PF on the left hand side, it becomes negative. So if we rewrite this, we get PR minus PF, that should give us FR. PR is 2.56 and PF is 0.36. Let's subtract this, 2.56 minus 0.36. 6 minus 6 0, 5 minus 3 is 2, 2 minus 0 is 2. So we get this value as 2.2 centimeters. Okay, so we've got PQ and we've got EQ and we've got FR. Now let's see what is what we get for PE upon EQ. So PE is given as 0.18, this is clear, and EQ is 1.1 centimeters. So I'll leave this over here and look for what is PF upon FR. PF upon FR. PF is given to us as 0.36 and FR is 2.2 over here. So if I divide this by 2, we get 2 ones are 2, 1.1 into 2 gives us 2.2. Over here we can get 0.18 because 0.18 into 2 gives us 0.36. So this comes to 0.18 upon 1.1. Now this two equal each other. So we say this implies that PE, or therefore you can say PE upon EQ is equal to PF upon FR. Okay, so we can say this implies that EF is parallel to QR. How? By converse of BPT. Correct? So I hope you have understood all these problems that we have solved based on the basic proportionality theorem and its converse. Okay, we'll be solving proofs based on BPT and its converse in the next video. So if you have liked this video, please click on the like icon, share it with your friends. Do not forget to subscribe. If you have already subscribed, wonderful. Please ask your friends also to subscribe to it. Do not forget to click on the bell icon, because through that we will be able to notify you whenever we post a new video. Thank you for watching. See you in the next video.